Hello and welcome to Alexander's journey through the galaxy, where one man and his telescope start a new and everlasting friendship, journeying together through space. Please like, comment, share this video, and most of all, subscribe. And welcome to this channel. Hello and welcome to the very first ever reading for this channel, and we will be reading out of Patrick Moore's book titled New Guide to the Planets, and I will be reading on Uranus. So sit back, relax with your favourite drink and listen. Uranus. 5 planets were known in ancient times, together with the Sun and Moon. This gave 7 members of the solar system, and 7 was a mystical number. Nothing could be tidier, and little thought was given to the possibility of a new major planet. Their matters rested until 1781, when a discovery by a then unknown musician astronomer took the astronomical world by surprise. William Herschel was born in Hanover, but came to England when still a young man, and became a professional organist. He settled in a fashionable spa of Bath, and soon built up an excellent reputation. His hobby was astronomy, and he began to make reflecting telescopes. He was also a first-class observer, and on the night of the 13th of March, 1781, he was using one of his homemade telescopes to examine stars in the constellation of Gemini, the twins, when he found something which was to alter his whole life. To quote from his own account, "In examining the small stars in the neighbourhood of H Geminorum, I perceived one that appeared visibly larger than the rest. Being struck with its uncommon appearance, I compared it to H Geminorum, and the small star in the quartile between Auriga and Gemini, and finding it so much larger than either of them, I suspected it to be a comet. Comets are interesting, but by no means uncommon, and at the time Herschel was not particularly excited. His first paper on the subject was headed An Account of a Comet, and he had no idea of the importance of what he had found. Then the mathematicians set to work, and the orbit was worked out. It was not in the least like that of a comet. Instead, the object was a planet, much more remote than Saturn, and moving round the Sun at a distance of 1,782,000,000 miles in a period of 84 years. Herschel suggested the name of Giorgium Sidus, or the Georgian Star, in the honour of King George III of England, and Hanover, who gave Herschel the status of King's Astronomer, not Astronomer Royal. That position was filled by Neville Maskelyne, and gave him a pension which enabled him to give up music as a profession and devote all his time to astronomy. Foreign astronomers were not impressed with the name, and neither did they accept Herschel in honor of the discoverer. Finally, the mythological system prevailed, and the new planet became Uranus, after the original ruler of Olympus. It is often said that the discovery was due to sheer chance, but this is unfair to Herschel, who was busy upon a systematic review of the heavens. As he said in a letter written to a friend of his, Dr. Hutton, "Had business prevented me that evening, I must have found it the next, and the goodness of my telescope was such that I must have perceived its visible planetary disk as soon as I looked at it. Probably the new planet could hardly have been missed for much longer, even if Herschel had never made a telescope. It would surely have been found by Scroter's celestial police." In the first years of the new century, when they set out to hunt for the missing planet between the orbits of Mars and Jupiter, though Herschel was the first to recognize Uranus, he was not the first to see it. It had been recorded several times in earlier years, and the first astronomer royal, John Flamsteed, saw it half a dozen times between 1690 and 1715, without realizing that it was anything but an ordinary star. He even gave it a stellar designation, 34 Tauri. Keen-sighted people can see it easily enough with the naked eye, when they know where to look. The mean magnitude is 5.7. Uranus ranks as a giant, though it is much smaller than Jupiter or Saturn. It is far larger than the Earth, with an equatorial diameter of 31,770 miles. The polar diameter is rather less, because the globe is appreciably flattened. Uranus is denser than water and much denser than Saturn, although the volume is 67 times that of the Earth. The mass is only 14.5 times as great. The escape velocity is 14 miles per second, with the surface gravity only very slightly greater than that of the Earth. Seen through a telescope, Uranus shows a pale bluish-green disk. There is no mystery about this. The cloud tops are so cold that the methane freezes out into clouds, which cover the ammonia clouds lower down. Methane absorbs light of long wavelength, i.e. red and orange, but not blue and green, hence Uranus' distinctive colour. In the atmosphere, hydrogen is dominant, with about 15% of helium. It would be quite wrong to think of Uranus as merely a smaller version of Jupiter or Saturn. The internal makeup is quite different. According to the latest modules, there is a core, which may or may not be well defined, surrounded by dense layers in which gases are mixed with ices, i.e. substances which would be frozen out if they were as cold as the upper clouds. It seems that the bulk of this mixture is composed of water, and that water, ammonia and methane condense in that order to produce the thick, icy cloud layers. This sort of situation was expected long before the Voyager 2 mission, and it has been confirmed from the spacecraft results. It is fair to say that Uranus and the outer giant Neptune are near twins, and that the Jupiter-Saturn pair is strikingly different from the Uranus-Neptune pair. Yet, even between the outermost giants there are differences. Uranus is unusual in having no internal heat source, or at best a very weak one, and it also has a most remarkable axial tilt. It is a quick spinner, though not as rapid as Jupiter or Saturn. We now know that the rotation period is 17.24 hours, rather longer than had been thought before the flight of Voyager 2, but as seen from Earth, the pole may sometimes lie in the centre of the disk. Most of the planets have their rotational axes moderately inclined to the perpendiculars to their orbits. With the Earth, the angle is 23.5 degrees. Mars is much the same. Saturn and Neptune slightly more, while Jupiter and Mercury are almost upright. Uranus has its own way of behaving. The axial tilt is 98 degrees, which is more than a right angle, so that the rotation is technically retrograde. This means that the Uranian seasons are peculiar, to put it mildly. First one pole and then the other will be in darkness for 21 Earth years at a time, with a corresponding midnight sun at the opposite pole. Though, for the rest of the revolution period, the conditions will be less extreme. But which is the North Pole and which is the South? This is a question which is not nearly so easy to answer as might be thought, and I well remember that at the press briefings at Mission Control in Pasadena during the Voyager 2 encounter in 1986, there was an endless discussion about it. The International Astronomical Union has decreed that all poles above the ecliptic, that is to say, the plane of the Earth's orbit, are north poles, and all those below the ecliptic are south poles. In this case, it was Uranus' south pole which was in sunlight when Voyager 2 passed by. However, the Voyager team members reversed this and referred to the sunlit pole as the North Pole. Take your pick. I propose to follow the IAU decision. The sharp tilt means that from Earth, we sometimes look straight at a pole and sometimes at the equator. In 1946, the North Pole lay in the centre of the disk, with the equator running around the edge. By 1966, the equator ran straight up and down, with the poles lying at opposite limbs. In 1985 to 1986, we again had a bird's eye view of a pole, this time the south one. By 2007, we will be back to having an equatorial presentation. Nobody has any real idea why Uranus is tipped in this way. The favoured theory is that at an early stage in its career, it was struck by a massive body and literally knocked sideways. I admit to being profoundly sceptical. I failed to see how a largely liquid body over 30,000 miles across could be jolted in such a way. But I am also bound to admit that I cannot think of anything better, though other factors to which I will return later indicate that something very unusual happened in the outer solar system several thousands of millions of years ago. Even large telescopes will show virtually nothing on Uranus's pale disk. In 1992, I had the chance to observe it with a 60-inch reflector at Palomar in California, and to me the planet was completely blank. I am unhappy about details shown on drawings made by observers with much smaller instruments. Uranus is a very bland world, and clearly much less active than Jupiter or Saturn or Neptune for that matter. Uranus has been suspected of short-term and long-term changes in brightness, possibly indicating changes in the outer clouds, although slight variations in the output of the Sun may also play a part. Amateur observations can be useful here and can be carried out in the same way as for variable stars, but making accurate estimates is not easy because Uranus shows a definite disk instead of appearing as a sharp point of light. I found this in May 1955 when Uranus was close to Jupiter in the sky. From 8 to the 11th of May, the two planets were in the same telescopic field, and I decided to estimate the magnitude of Uranus by comparing it with the Galilean satellites of Jupiter. Using various magnifications on my 12.5-inch reflector. Alas, I failed. Uranus looked larger than any of the Galileans, but it was also much dimmer, area for area, and I found that I was quite unable to make any reliable comparisons. It is hardly necessary to add that the two planets were not genuinely close together. They simply happened to lie in the same direction as seen from Earth. Uranus is more than 3 times as far away from us as Jupiter. Another way in which the amateur can help is by observing occultations of stars by Uranus. The problem being that because Uranus moves so slowly, occultations are rare. However, one occurred in 1977 and led to a most important discovery. The date was the 10th of March. The star concerned was of the 8th magnitude. The occultation was observed from various stations, including the Cuvier Airborne Observatory, which is an aircraft specially modified to carry a large reflecting telescope. Both before and after the occultation, the star winked several times. The only possible explanation was that the star was being briefly hidden by dark rings associated with Uranus. Subsequently, the rings were actually observed using special infrared techniques, and even before the Voyager 2 mission, we had found out a good deal about them. The system is quite extensive, but there is no comparison with the glorious rings of Saturn, which are brilliant and icy. The Uranian rings are as black as coal dust, and they are very narrow. 5 satellites, Miranda, Ariel, Umbriel, Titania, and Oberon, were known in pre-Voyager days. All are smaller than our moon, and even Titania, the largest, has a diameter of no more than 981 miles, so that it is comparable with Rhea and Leptis in Saturn's family. It was generally expected that all the satellites would be icy and cratered. Whether or not Uranus had a magnetic field, and whether it sent out radio waves, had to wait for the Voyager results. Voyager 2 had a long flight since leaving the neighbourhood of Saturn in 1981. Moreover, it had not been trouble-free. The scan platform carrying the main camera had stuck at the very end of the Saturn encounter, and for a time it was feared that it would never be freed. Apparently, it had not been sufficiently lubricated. However, on arrival at Uranus, all was well, and Voyager performed faultlessly throughout. This was a new sort of encounter because the spacecraft would approach its target pole on. So to speak, it was rather like aiming for a bullseye the centre of a dartboard, the ball, in this case being Uranus' southern sunlit pole. The first major discovery came on the 30th of December 1985, almost a month before closest approach. Voyager located a new satellite, closer to Uranus than Miranda, the innermost of the previously known moons. Following the Shakespearean tradition, it has been named Puck. 9 other small satellites followed, and one astronomer commented that it looked as if the Almighty had taken a shaker and scattered satellites in all directions. All were midgets. Even Puck, the largest of them, is less than 100 miles across. Voyager managed to obtain a picture of it, showing it to be a darkish and crater-scarred. The largest satellites were also icy, but were not alike. Oberon's craters tended to have darkish floors. Titania showed not only craters but also valleys and ice cliffs. Umbria was more subdued and seemed to have an older surface, though there was one feature close to the limit of Voyager's view which was brighter and might possibly have been seen as a crater if it had been better placed. It has been named Wanda. Ariel has broad branching valleys which look very much as though they have been cut by liquid, but all the satellites are too small to retain any trace of atmosphere, so that it's not easy to show how liquid water can never have flowed on Ariel. Miranda was the showpiece of the system. It has an immensely varied surface. There are cratered plains, bright areas with cliffs and scarps, and coronae, large trapezoidal-shaped regions which look rather than race tracks. Miranda itself is less than 300 miles across, and its strange surface is very much of a puzzle. It has been suggested that early in its career it was broken up by collision with a larger body and reformed later, but we do not really know. The rings were well seen. There were 10 of them altogether, plus a broad sheet of tenuous material stretching down from the innermost ring almost as far as the cloud tops. The broadest ring is the outermost, known as the Epsilon ring, which has 2 shepherd satellites, Cordelia and Ophelia, which are of course Voyager discoveries. The last picture taken as Voyager was drawing away from Uranus shows that there is a great deal of dust in the ring system. The rings themselves seem to be made up of particles a few feet across, and they cannot be as much as 1 mile thick. Few clouds were seen as Voyager 2 closed in. There were none of the disturbances seen on Jupiter or Saturn, and Uranus appeared to be depressingly featureless. Eventually, some obscure clouds were seen, and radio emissions were picked up, altogether with indications of a magnetic field. It was then found that the magnetic field is reversed relative to ours, so that what we call the north pole of rotation is magnetic south. But in any case, the magnetic axis is inclined to the rotational axis by almost 60 degrees and does not even pass through the centre of the globe. This is certainly very odd and was quite unexpected. It means incidentally that Uranian aurorae are much more conspicuous near the globe's equator than near the poles of rotation. The magnetosphere spreads out to 370,000 miles on the day side of the planet and 3,700,000 miles on the dark side, which means that all the members of the satellite family are immersed in it. Observations made at short wavelengths showed strong emissions on the day side, producing what is now termed as an electric glow, unlike anything else we have so far found in the solar system. In many ways, Uranus is the odd one out among the giant planets. It alone lacks any marked internal heat source. It alone has an extreme axial tilt. It shows very little surface activity, and there is virtually no difference in temperature between the equator and the poles. From Uranus, the Sun will have an apparent diameter of only 1.5 minutes of arc, less than twice the apparent diameter of Jupiter as seen from the Earth, but it will still be very brilliant, casting as much light as 1,000 full moons. Little could be seen of the other planets. Saturn would be a naked eye object, but would remain close to the Sun in the Uranian sky, never moving much further out than Mercury does to us. It would be an inferior planet, best seen every 22 and 3/3 years. Jupiter would never be more than about 17 degrees from the Sun. It would seldom be visible without optical aid. Neptune, of course, would be reasonably bright when at or near opposition, but it would be out of view for long periods, when it and Uranus are on opposite sides of the Sun. Remember too that on average, Uranus is only 1.5 times closer to Neptune than we are. Maps tend to be deceptive, and it is quite wrong to suppose that the two worlds are near neighbours, just as some Europeans fondly imagine that New Zealand is almost within hailing distance of Australia. It is by no means difficult to identify Uranus. Between 1989 and 1995, it remains in Sagittarius, the Archer. It then moves into Capricornus, the Sea Goat, and will remain there until the end of the century. Binoculars will show that it is unlike a star, and a telescope will magnify it into its tiny bluish-green disk. It is an interesting and strange world, and it also has the distinction of being the first planet to be discovered by a modern man. Thank you for listening to me talk about Uranus. I do hope that you found this video interesting. Please leave a thumbs up, a comment, and please subscribe and share. Until the next time I read to you about something new in the galaxy, take care, and I look forward to seeing you again real soon. Bye bye.